Welcome to solverfy.
Okay, so question 1 was asking us what multiple of lambda gives their phase difference after they both have emerged from the layers. So the question was asking us the difference in phase difference. So we know the equation for phase difference is capital N2 minus capital N1 equal to L over lambda times N2 minus N1. And so the lambda is wavelength, okay? So the phase difference between the two waves after traveling through a length of median L2 can be given as N2 N2 minus N1 equal to L2 over lambda times lower letter N2 minus N1, okay? And so the phase difference between the two waves after traveling through a length of median L1 minus L2 can be given as N2 minus N1. Let's put 1 here, okay? And this is 2. Can be given as L1 minus L2 over lambda times the index of refraction of the air, which is N air, minus N1, okay? So N air is the refractive index of air. And why I plug in N air here is because the light wave enters into the air medium after traveling through a length L2. So if we combine the equations we have here to get a total phase difference between the waves after emerging from the two layers, we'll get just simply adding them together, which is the N2 minus N1 1 plus N2 minus N1 2 will give us delta N2 minus delta N1. So delta N2 minus N1 is equal to N2 minus N1 1 plus N2 minus N1 2. And this will give us L2 over lambda times N2 minus N1 plus L1 minus L2 over lambda times N air minus N1, okay? So now we have the equations. Now we can plug in a value, which is L2 is given as 3.5 micrometer, which is 3.50 times 10 to the power of -6 meter, since 1 micrometer is 10 to the power of -6 meter, over lambda, which is given as 600 nanometers. So it's 600 600 times 10 to the power of -9 meter times N2 minus N1, which is 1.6 minus 1.4. So it's just simply 0.2, okay? Plus L1 minus L2. L1 is given as 4 micrometers, so it's 4 micrometer minus 3.5 micrometer, which is 0.5 micrometer. So L1 minus L2 is 0.5 micrometer. But remember, micrometer is equal to 10 to the power of -6 meters. So 0.5 times 10 to the power of -6 meter is L1 minus L2 over lambda, which is 600 times 10 to the power of -9 meter, okay, times N air minus N1, which is 1 minus 1.40. The index of refraction in air is just 1, okay? So that's why it's 1 minus 1.4. And we'll get delta n2 minus n1 is equal to 0.833. Okay. So the phase difference between the two emerging rays is equal to 0.833 times the wavelength of the light wave. Okay, which is 0.833 of lambda. Okay, so the multiple is 0.833. So for question B, it was asking us, is it fully constructed or fully destructive, or is it intermediate but closer to fully constructive or fully destructive? Well, the answer is intermediate but closer to fully constructive. Okay, so intermediates but closer to fully destructive. Okay. Well, I'm sorry, fully constructive. Well, so why is that? Well, if the path difference between the two interfering waves is equal to integral number of wavelengths, then the two waves undergo constructive interference, while if the path difference is equal to half integral wavelengths, then the two waves will undergo destructive interference. The fraction obtained in part A, in question A, okay, is intermediate between 1/2 and 1, but closer to 1, okay? So therefore, the interference, it must be intermediate but closer to fully constructed, okay? So this is the solution for the question. Thank you.